Robert Frost famously noted that some say the world will end in fire/some say in ice. Lucky us. We're pretty sure we know the answer, it's ice. But how long do we have until the end of time, and what will it look like? When the word first got out that the expansion of the universe was accelerating, many astronomers questioned the results. They felt that the observations must be wrong, or the interpretation must be flawed. The whole concept was so difficult to believe because it requires significant changes in our understanding of the way the universe works. I would say that the Big Freeze scenario is the most likely, as the universe keeps expanding on forever and ever and ever and ever, until nothing but subatomic particles remain. There are quite a couple of scenarios of the ultimate fate of the universe, with most stating it will end, although there is a theory that the universe will just keep going on forever and ever. I will not talk about how humanity would advance, just the effects on Earth and the universe. For this case, I will take the Big Freeze scenario, as it is the most likely. I'll be going through the important events that may occur on Earth and in the universe. Ready? Let's go. 1,000 years later. By the time 1,000 years pass, most of our languages would be gone, forgotten, and never spoken ever again. Any language that does survive will have been changed so much it would never sound the same to us, and the grammar and words we use now will be gone in this time, like how we view Shakespeare's English. 2,000 years later. Global warming would still be going on and the Earth's temperature would have risen by 8 degrees Celsius. The ice sheets and glaciers in Greenland mostly melt away, rising sea levels by 6 meters, potentially disastrous for low-lying poor countries. 13,000 years later. Earth's axial tilt will reverse, and along with it, seasons. Northern hemispheric winter starts in June. The northern hemisphere will suffer from the extreme weather since there is more land above the equator. Either we live with it, or migration to the southern hemisphere begins. Carbon dioxide levels are dropping slowly. According to Carter's doomsday argument, humanity has a 95% chance of being extinct, although in this case, I will take this as perhaps false. 20,000 years later. Chernobyl becomes habitable once more. 25,000 years later. The Arecibo message, a collection of radio data transmitted on November 16, 1974, reaches the distance of its destination, the globular cluster Messier 13, at the far side of the galaxy. Any alien race that manages to receive the message will know that they are not alone. The reply message will only be received by us 25,000 years later. The northern polar ice cap on Mars will recede due to a warming period. Human colonists on Mars could expand north if they still exist. 30,000 years later. All fission-based breeder reactor reserves run out, forcing humans to swap to another energy source. 50,000 years later. The Niagara Falls would have eroded the remaining 32 km to Lake Erie and have vanished. The global temperature would have increased by another 2 degrees Celsius, completely melting away all the ice in Greenland. According to Berger and Lutry, Earth plunges into another ice age despite global warming. This ice age could possibly be delayed by constant burning of fossil fuels. If any aliens have replied, we would receive the Arecibo reply by this time. 85,000 years later. By this time, it is safe to assume that the world will have completely changed by this time. If humanity hasn't been wiped out, no nation, religion or way of life will be the same. There would be new factions or hopefully a world coalition government, with no countries left. Religions like Judaism and Christianity that have persisted for so long would have been forgotten and given way to new religions, or religion may no longer be existent. 100,000 years later. V. Canis Majoris will explode into the largest hypernova seen in the universe, probably even visible from Earth. Earth would most likely suffer a supervolcanic eruption, likely the Yellowstone caldera, that will hurl ash into the sky, blocking out sunlight and lowering temperatures, causing a global disaster. Titanium begins to corrode away. By this time, should humanity have the technology and the survival, terraforming of Mars will near its ending phases, with a now oxygen-rich atmosphere. I predict that most of humanity will live on Mars by now. 296,000 years later. Voyager 2 passes within 4.3 light-years of Sirius. Any intelligent aliens will probably recover it and find the golden record and realize that they are not alone. 500,000 years later. Earth is struck by a 1-kilometer asteroid that has an impact of 6 times 10⁴ megatons, equivalent to an earthquake of magnitude 9.4 on the Richter scale. This isn't an extinction event, not even close, but causes significant damage to Earth's environment and could wipe out any humans still living on Earth. If we have just kept burning fossil fuels, the Ice Age can be delayed until this time. Spent nuclear fuel in reactors would also be safe by this time. 1 million years later. Glass left on Earth would have fully decomposed by this time, and so will every structure that we have today, except for stone structures like Mount Rushmore or the pyramids of Giza, although the pyramids would probably be unrecognizable. Nearly everything we left on the moon will also be gone. Humanity, if still alive, would have spread throughout the galaxy. This is the shortest time it will take for humans to colonize the Milky Way. 2 million years later. Coral reefs will finally physically rebuild and biologically recover from current human-caused ocean acidification. The Grand Canyon will further erode into a wide valley. 7.2 million, 7,200,000 years later. Mount Rushmore erodes away. Basically, nothing left of human civilization will be left, except for our trash. There will be little trace of any intelligent species that lived here. If aliens finally visit after receiving a message or info, they may find nothing. 10 million years later, mass extinction. Earth is hit by a gamma-ray burst from the supernova of nearby star Tepexides that irradiates the planet, destroys the ozone layer and triggers a mass extinction. Funny, seeing how 10 million years is the time it takes for the Earth to recover from the Holocene extinction that humans cause. So Earth went from one mass extinction to another. The East African Rift Valley is flooded, causing a new ocean basin to divide Africa. 27 million years later. By this time, Homo sapiens will go extinct and what remains of humans will be another step in evolution. Humans, having spread into space, may split into different species due to going separate ways through the cosmos, possibly leading to wars between different species of future humans. By this time, humanity will have advanced so far that things like nuclear fusion and basic space flight will be practically primitive to them and they may scoff at us working so hard to land a rocket. 50 million years later. By this time, if humanity did indeed set out to colonize the Milky Way, this is the time when we would have finally conquered the galaxy, presumably exterminating life and waging wars against aliens inside the Milky Way. Europe and Africa collide and merge to form one continent, allowing animals to cross and spread. Indonesia and Australia also merge together at roughly the same time. Many mountain peaks start to erode, and Earth starts to draw to a close. It would still take hundreds of millions of years, but Earth starts to slowly die. The universe, however, is nowhere close to ending yet. Antarctica, moving north, finally melts all of its ice, rising seas worldwide by 75 meters, causing massive floods in practically every region. Mars will have its moon, Phobos, smash into it, potentially causing a mass extinction of any Martian life that exists after terraforming and if still colonized, perhaps human colonies too. However, there is the possibility that this is averted. I'm not here to say what the tech prowess is for future us. Next. 100 million years later. Earth will likely be hit by a huge asteroid, similar in size to the one that caused the KT extinction that killed the dinosaurs. With likely no humans left on Earth, this asteroid will not be deflected and can potentially cause a mass extinction, again. Earth's orbit will no longer be nearly uniform, but rather completely random, having devastating impacts on Earth's climate and ecosystem. Saturn's rings will have disappeared, and according to Drake's equation, this will be the furthest humans will ever get to an advanced civilization. 250 million years later. Due to tectonic plate movement, all continents on Earth will have joined in one of three configurations: Amasia, Novo-Pangaea, and Pangaea Ultima. 600 million years later, Earth starts to end. The Sun has increasing luminosity, something with carbonate silicate cycle or something, sorry bad chemist, and water starts to evaporate, rocks harden, and plate tectonics screech to a stop. Without this, no more volcanoes exist, thus causing carbon dioxide levels drop. This eventually renders C3 photosynthesis impossible and kickstarts the greatest extinction in history, with around 99% of plant life dying. No plants equals no herbivores equals no carnivores. 800 million years later, extinction. Carbon dioxide levels continue to plunge until C4 photosynthesis is no longer possible. Free oxygen and ozone disappear from the atmosphere. Every multicellular lifeform dies, leaving only unicellular organisms remaining on a now desolate and barren world. I would assume that most intelligent life in the universe will begin dying off by 1 billion years into the future. 1 billion years later. The Sun's luminosity would have increased by 10%, causing Earth's surface temperature to be 47 degrees Celsius. The atmosphere will become a moist greenhouse, resulting in a runaway evaporation of the oceans. This turns Earth into a dry, arid planet, and many unicellular organisms that require water to live, die off. Pockets of water may still be present at the poles, allowing some simple unicellular organisms to live on. This is also the estimated time needed for an astroengineering project to finish to drag Earth away from the brighter sun, but I find it unlikely that our descendants survived this long, and would most likely have abandoned Earth. The golden records of the two Voyager spacecraft lose all their information. Aliens will never find out about Earth again. 1.3 billion, 1,300 million, years later. Carbon dioxide runs out. Every cell with a nucleus perishes, leaving only cells without nuclei left on the barren ruined world once called Earth. Mars could potentially become habitable without the need of human terraforming a few million years after this. 2.3 billion, 2,300 million, years later. The outer core of the Earth freezes as it loses heat out to space, and the inner core keeps growing. The Earth stops spinning and the magnetic field shuts down, and the now unprotected remnants of the atmosphere are depleted by the Sun. 2.8 billion, 2,800 million, years later, RIP life on Earth. Earth's surface temperature hits a 149 degrees Celsius. This, combined with a lack of atmosphere, finally kills all life on Earth. Nothing survives this. The Earth will no longer sustain unicellular, non-nuclei containing organisms. The heartbeat of the Earth flatlines. 4 billion years later. The Milky Way galaxy collides with the larger Andromeda galaxy and will eventually, tens of millions of years later, merge to form Milkomeda, probably the dumbest name ever. The collision could potentially disrupt the orbits of hundreds of millions or billions of stars and their planets. The solar system will also be sent flying from its original position, but is expected to be relatively unaffected. 5.4 billion, 5,400 million, years later. The Sun's hydrogen supply at its core is finally exhausted. The Sun starts to evolve into a red giant and expands outwards towards the inner planets. In a few billion years, the Earth, and Mars will become tidally locked and have their surfaces superheated and scorched. 7.9 billion, 7,900,000,000, years later. The Sun reaches its maximum radius, 256 times its normal, and consumes and destroys Mercury and Venus. Earth's moon breaks up into debris which falls down into the desolate Earth, which is then either consumed or fully scorched. Mars would probably not be consumed, but would not be habitable. It is theorized that Saturn's moon Titan can support life now. 8 billion, years later. The Sun shrinks back into a white dwarf, with about 54.05% its present mass. If Earth has not been destroyed, the scorching temperatures will drop rapidly, as with the temperature of every other celestial body in the solar system. All that's left of the solar system is a few cold, bleak planets and moons with no capability to support any form of life ever again. 14.4 billion, 14,400,000,000, years later. After a few billion years as a white dwarf, the Sun converts into a black dwarf, with low temperatures and practically zero luminosity, turning invisible to the eye. It is now nothing but a cold, dark carbon ball. The Sun thus ends its long lifespan. However, there are a large number of scientists who believe that it would take quadrillion years for the white dwarf to turn into a black dwarf. 100 billion, years later. With the Big Freeze scenario, the universe keeps on expanding. This causes all galaxies beyond the Milky Way/Milcomedes local group to disappear beyond the observable universe. It is very likely that any intelligent species that somehow manages to arise at this time will never see another major group of galaxies ever again, and may even conclude that their local galaxy group is the only thing in the universe. By this point, the Big Bang is no longer detectable, perhaps causing any intelligent species left to believe that the universe had no beginning and maybe no end. Local galaxies also start to merge together. 1 trillion, years later. No new stars will ever be produced as the gas clouds needed to form them no longer exist in the lonely giant galaxies floating around. Stars slowly, one by one die out and the sky turns black, leaving the planets still floating around the dark. The local group finishes merging together and it would be the only thing floating in space as everything else is too far away. 30 trillion, years later. Stars in their stellar neighborhoods start undergoing close encounters with other stars, disrupting the orbits of stars and their planets, sending both the planets and moons and stars flying out of the galaxies entirely. These stars will go hurtling through the now empty cosmos, alone forever until they die. 100 trillion, years later. By this time, absolutely no free hydrogen existing to try to form new stars. The universe enters what is known as the degenerate era. 120 trillion, years later. Almost every existing star in the universe finally burns out and they die off, with the red dwarfs the last to go. The only things left in the universe would be brown dwarfs, white dwarfs, neutron stars, and black holes, which will then slowly, very slowly, die off in that order. The only real bright lights are supernovas when these stars collide. A neutron star, that will be one of the last things in the universe. 100 quintillion years later. Well over 90% of all the aforementioned celestial bodies have already been ejected out of the slowly dispersing galaxies that are also being consumed by black holes. Most of everything is now solitary, never to see anything else again. The solar system is finally destroyed when every planet collides with the black dwarf that was the Sun, which then decays away or is consumed by a black hole. 1 nonillion years later. Every star still not ejected is consumed by the supermassive black holes, along with every galaxy still not dispersed yet. Only solitary objects manage to survive the supermassive black holes. The brown dwarfs still won't die until many quintillion years later. Most of the universe is gone, but the universe isn't even halfway through its full lifespan yet. 3 times 10 raised to the power of 43 years later. Every brown dwarf, white dwarf, and neutron star have already decayed away into nothingness by this point, leaving only black holes in the entire universe. These dark celestial objects will remain for far longer than one thinks. The universe still isn't halfway through. In fact, black holes probably last longer than every other celestial object combined. 1.342 times 10 raised to the power of 99 years later. Almost every black hole has already dissipated due to the emission of Hawking radiation, leaving just one gargantuan supermassive black hole left, already dissipating away as well. 1 Google, 1 times 10 raised to the power of 100, years later. The last black hole has finally died. There is absolutely nothing left in the universe other than subatomic particles. The universe continues to expand further and further away, spreading these subatomic particles so thin, that they will never, ever, interact with another particle ever again. The universe hits a tiny bit above absolute zero. Nothing left.